Alright, so this is the last video for our section 10.2. It's significance tests for the mean difference. So it's going to be pretty cool. All our conditions that we've been doing in the past are still the same. Okay? Instead of writing them out again, you guys should know those by now. Okay? We're going to have let's do this. Let's do a 2-sample t-test for the difference. Okay, so we're going to go h naught mean 1 minus mean 2 is equal to 0. Our alternative hypothesis is going to be, of course, everything else we've already done. We're going to either have a one-tail test or a two-tail test. Oops, there you go. So there's your null hypothesis and there's alternative hypothesis. You're either going to have one tail, two tail, just like normal. All right. Our t is going to be x bar 1 minus x bar 2 minus the mean 1 minus the mean 2. That's usually going to be 0 for us unless they tell us specifically what it is going to be. It's going to be 0. Okay. And then we're going to divide this by the sample standard deviation squared of sample data 1 divided by the n of 1 plus sample squared data, sample deviation squared data of sample 2, and that's n2 as well. Then we're going to take the square root of that. Our degrees of freedom is going to be either using technology, that really long formula that we've talked about in the previous ones, or the smaller of n minus 1 or of n1 minus 1 or n2 minus 1. Okay? Okay. So let's go to an example. It's going to be titled Leaking Helium. All right. So it starts off with buying many helium balloons only to see them deflate within a couple of days. Aaron and Jenna decide to test whether helium-filled balloons deflate more quickly than air-filled balloons. To find out, they bought 60 balloons and randomly divided them into 2 piles of 30, filling the first pile with helium and the balloons in the second pile with air. Then they measured their circumference of each balloon immediately after it was filled and again 3 days later. The average decrease in circumference of the helium-filled balloons was 26.5 centimeters, with a standard deviation of 1.92 centimeters. The average decrease of the air-filled balloons was 2.1 centimeters, with a standard deviation of 2.79 centimeters. Question: do these data provide convincing evidence that helium-filled balloons deflate more quickly than air-filled balloons? And interpret the p-value you got in part A in the context of the study. Okay. So what we're going to do is we are going to move into and then let's move this back. Let's pause it for just a second. All right, so let's work on our solution. So let's do our 4 conditions. Independence. I'm going to say check. one balloon won't affect the next. Okay. Random. Check. It was stated. Next one's 10% condition. And 30 balloons for each set is less than or equal to 10% of all balloons. So I think we're good there. All right. Large counts. Very nice. N is equal to 30. So we can proceed to a 2 sample t-test. All right. I like the fact that they gave us this large counts. That was nice. All right. So H naught, the mean difference, has got to be 0. Our alternative hypothesis, all right, it says that does the helium deflate faster? So I'm going to go like this, and I'm going to come out here and say let mu1 be the mean difference of the helium filled balloons. I'm going to put down here and say let mu2 be the mean difference of the air filled balloons. Okay, so now we've labeled everything. We've got our 4 conditions. We've done really well. So we're going to do our T real quick. So the mean of the helium was 26.5 minus 2.1 minus 0. And then we've got our standard deviation for the other guy was 1.92 for the helium. Don't forget to square it. The size was 30 plus 2.79 squared divided by 30. And I'm going to take the square root of that. Okay? Little magic. You should get something close to this, depending on when you're rounding and that type of thing. Okay? All right. So our degrees of freedom, because it's 30, is going to be 29. Because I didn't want to use technology yet, I'm just going to use my chart real quick. Should have paused it. Oh well. Okay. So 29. I am looking for 39. So if I come to here, oh sorry, here's 29. I'm looking for 29. It's not on there, is it? So that being the case, our p-value is basically 0. Because if you remember, I go all the way across till I find it, then I come up and it kind of gives me the range of where it's going to be for the chart. And so this one's telling me, hey, it's not in there. Okay? So, and plus 39, that gives us why it's going to be 0. Okay? All right, now, that means our p-value is 0, They didn't tell us the significance level, so because they didn't tell us our significance level, we're going to be using the 0.05. Obviously that's bigger, and we're going to reject the null hypothesis. So then we'd come up to here and say there is convincing evidence that the helium filled balloons deflate more quickly than the air-filled balloons. Okay? Part B, we're going to come to here and say, okay, well, we're going to assume that H naught is true. Okay, we already showed that it's not, but we're going to say that it is. Then there is basically a 0 chance of getting a difference of coming up here. If I subtract those two, it's like 24.4 by chance alone. Okay? Oh, my ugly face is covering it again. Okay. So that's doing it without our calculators, okay? So our calculators, what we're going to use is we're going to use something called a two-sample t-test. Okay? So I'm going to go to I apologize. I'm going to go to my stats, go to test. I'm going to go down to two-sample t-test. You can see that I've already entered my data. There's my mean for the X1. There's my standard deviation for the helium. There's the sample size all the way down. Pool's always going to be no. Okay? I'm not going to try and go explaining anything. It's too much over this wireless and everything like that. You're going to choose no every time on the pooled, okay? So we'll come down here. We're going to hit calculate. We get a different t value, 39.46. Hey, actually it's the same one. But our degrees of freedom is different. 51. So they're using that technology. Okay? But this is saying there are 39 zeros in front of that 1. So basically it's 0. Okay? So there is pretty strong evidence that helium balloons run out of air faster. Okay? Alright. I think I forgot to do this on the last video, but I'll put it on this one. So the last homework is going to be 42, 44, 46, 48, 54, and 57 through 60. Keep on keeping on. We'll see you guys. I'll send out another email about what's going to happen and what we need to do, okay? Talk to you later.